Hello, so this is lesson 3.3, and we are going to be dividing polynomials and talking about remainder and factor theorems. So, again, uh, please feel free to pause the video, or if you've got any questions, let me know. So we're going to start with long division of polynomials. Now, before we actually do that, we're going to go ahead and remind ourselves, how do we do a long division with numbers? So for example, if I have, let's say, uh, 2,354, and I am dividing this by 6. So 6 does not go into 2, so we're going to have to take the 3 with us. So 23. 6 goes into 23 3 times. 3 times 6 is 18. So we multiply 3 times 6, put 18 under, and subtract. We need to borrow 1 from the 2 to get 13 here. So 13 minus 8 is 5, and 1 minus 1 is 0. Now we need to bring the 5 down. And this needs to be less than our divisor, which is the 6, for it to be correct. So 55, 6 goes into 55 9 times. We put the 9 up here. 9 times 6 is 54. We subtract again. 5 minus 4 is 1. That is less than 6. We're going to bring the 4 down. How many times does 6 go into 14? 2 times. 2 times 6 is 12. And we have a 2 as a remainder. Now, we can write it like this, or another way to write this number would be 392 and 2/6. Now, of course, with the numbers, the 2, 6. So the 6 comes from the divisor. That goes here. The remainder goes on the as the numerator. Now with the numbers, we would, of course, simplify this to 392 and 1/3. But with the, and there might be times when you do simplify the numbers on the remainder as well. But we can write the remainder as R2, or we can write it as a fraction, a mixed number, or the remainder is the fraction part of the mixed number. Okay, so let's look at, so what we're going to do is, this first part is very important here. Make sure that you are arranging the terms of both the dividend and the divisor in descending powers of any variable. So it has to be descending powers. And then number 2, we're going to divide the first term in the dividend by the first term in the divisor. And the result is the first term of the question. Then number 3, just like we did with the 6, we're going to multiply every term in the divisor by the first term in the question and write the resulting product beneath the dividend with like terms lined up. Number 4, we're going to subtract just like we did with the numbers. Then 5, bring down the next term in the original dividend, just like we did over here, and write it next to the remainder to form a new dividend. And then use this expression as the dividend and repeat this process until the remainder can no longer be divided. So now, just the division algorithm. If we have f of x and d of x are polynomials with d of x does not equal 0, the degree of d of x is less than or equal to the degree of f of x, then there exist unique polynomials q of x and r of x such that, so fx equals d of x times q of x plus r of x. So the remainder r of x equals 0, or it is of degree less than the degree of d of x. If r of x is 0, we say that d of x divides evenly into f of x, and d of x and q of x are factors of f of x. Okay, so let's go ahead and look at what this all means. So first, if we look at our dividend here, we need to rearrange it in a descending powers. So we need to rewrite it as 2x cubed minus 3x squared minus 11x plus 7. And I'm actually gonna rewrite it here. 2x cubed minus 3x squared minus 11x plus 7. That is our dividend. Our divisor is x minus 3 over here. Now, we are not going to start, since we have a binomial, we've got 2 here. We're not going to start with this first one. Well, no, sorry. Let me take my words back. Yes, we are starting with this first one, and we are only looking at the x. So what we're going to do is how many times does x go into 2x cubed? So what I like to do, we're just dividing the 2x cubed divided by x. Well, this gives us 2x squared. That's a power of 1. We subtract powers. 3 minus 1 is 2. Now, this 2x squared goes on the top of the same degree. So notice this is a 2 and this is a 2. Now, for us to know what we're going to write under these two, we're going to have to take the 2x squared and multiply it by the dividend. And I'm sorry, the divisor, x minus 3. So we need to distribute. 2x squared is 2x cubed, and 2x squared minus 3x is minus 6x squared. Now we're going to take this and write it under here, 2x cubed minus 6x squared. Remember, we are subtracting. So what this means, we're flipping the sign. So this becomes a negative and this becomes a positive. So negative 3x squared plus 6x squared is going to be 3x squared. And then this is combining like terms. And this is going to be a 0. So 0 plus 3x squared. We can ignore the 0 now. Next, we're going to bring this next term down with its sign. Excuse me, I've got something in my throat. So negative 11x comes down. So what we're going to do now is we're going to look at the 3x squared here and the x. So 3x squared divided by x is going to be 3x. Sorry. So the 3x, and that's just an underlining of that. Oops. That was not what I meant. I was going to just take that. This is 2x squared. Okay, so this 3x goes on the top here now. It is a plus because we got a positive. Now we're again going to take this 3x and multiply it by the divisor, which is the x minus 3 here. So we're distributing. 3x times x is 3x squared. And 3x times negative 3 is negative 9x. We're going to write this here under right here. Again, we're subtracting, so we're flipping the signs. Negative 11x plus 9x is negative 2x, and the 3x squared and 3x squared cancel each other out. We are bringing the 7 down, and now we're going to go ahead and look at negative 2x. So negative 2x divided by the x here. That is negative 2. So the negative 2 goes up here, and notice again, we have a 7 here and a negative 2, so they don't have x's. So like terms are aligned. Okay, negative 2, we're going to multiply that by, again, the divisor, so x minus 3, distributing negative 2x plus 6. I forgot the x. Negative 2x plus 6 here. Remember, we're subtracting, so we're flipping the sign, so this becomes a negative. 7 minus 6 is 1, and negative 2x and 2x cancel each other out. So what this means is that we have a remainder of 1. It is less than x minus 3. We're not able to divide it any farther. So our answer here, we're going to write the remainder plus 1 over the divisor, x minus 3. And this is our answer. Now, what we could do is we could go backwards and take this, what we just got, as the quotient, the answer, and multiply it by x minus 3 to get to check to make sure that we get this one right here. So our original one. Just like we can do that with long division with numbers. Okay, so this was the long division of polynomials. Now we're going to look at what's called a synthetic division. It is a little bit shorter, a little bit different. So step number 1, arrange the polynomial in descending powers. So again, descending powers with a 0 coefficient for any missing term. And actually what I forgot to remind you here, even with the long division, what you would do is you would kind of either add a 0 times something or leave it blank so that you have the 3, 2, 1, and the constant. Next, we're going to write c for the divisor, x minus c. To the right, write the coefficients of the dividend. And then write the leading coefficient of the dividend on the bottom row. 4 multiply c times the value just written on the bottom row. Write the product in the next column in the second row. And 5, add the values in this new column, writing the sum in the bottom row. 6, repeat this series of multiplications and additions until all columns are filled in. And 7, use the numbers in the last row to write the quotient plus the remainder above the divisor. Okay, so let's start this before, so that you can see what we're doing here. So we are using x cubed minus 7x minus 6. So our we are using the coefficients of these. Now, we're missing one term here. And first of all, x cubed, again, doesn't have a coefficient, so we're going to write 1 in front of it. That's the understood one. Next, we don't have x squared, so that would be 0 times x squared because that's a 0 and it's not written. Next, we have negative 7x and minus 6. Okay, every single term has a coefficient. So the 1 goes first, 0 goes next, negative 7 and negative 6. Now, we're going to go ahead and draw like half of a box. And our x plus 2. So x plus 2 equals 0. If I move the 2 to the other side, I get x equals negative 2. This is the number for the divisor. So negative 2 is going to be our divisor right here. And there's a little bit different ways how the boxes are written, I've noticed, depending on the teacher and the book and all that. But so if you've learned another way, go ahead and use it. But basically it should, the steps are the same. There's not no other steps here. Okay, number 3, write the leading coefficient of the dividend on the bottom row. So what we're going to do is we're going to bring this one down here. Next step is multiply c times the value just written on the bottom row. So 1 times negative 2 is going to be negative 2, and it goes on the next column in the second row, right where I wrote it. Okay, next we're going to add the values in this new column, writing the sum in the bottom row. So 0 plus -2 is going to be -2. Again, we're going to take this -2 and multiply it by -2, which is 4, and that goes here. We're going to add -7 plus 4 is -3. We're again multiplying -3 times -2, which is a +6, and we are adding -6 plus 6 is 0. So this means that we have no remainder. Now, when we are writing the our answer, use the numbers in the last row to write the question plus the remainder above the divisor. The degree of the first term of the question is 1 less than the degree of the first term of the dividend. So dividend, we have x cubed. This will be 1 less because we just divided it. So x squared minus 2x minus 3. This is our quotient. And now, if we want to check that we did it correctly, we would take the x plus 2, which was our divisor, multiply that by our quotient, so x squared minus 2x minus 3, and we should get x cubed minus 7x minus 6, which is our dividend. So that would just be multiplying the two polynomials to check. Okay, next we're going to look at what's called the remainder theorem. So if the polynomial f of x is divided by x minus c, then the remainder is f of c. So we have 3x cubed plus 4x squared minus 5x plus 3. This is in a descending order, and it's not missing any terms. So we're going to write the coefficients, 3, 4, -5, and 3. And now we're using -3 here as the divisor. Again, it's because x is -4, we can use that as the divisor. Same thing, we bring the 3 down. We multiply 3 times -4 is going to be -12. We add 4 minus 12 is -8. -8 times -4 is 32. We add -5 plus 32 is 27. Then we multiply 27 times -4, and you can just go ahead and grab that calculator to do it. It is -108. I just moved the 3 a little bit farther so that I've got enough room. 3 minus 108 is -105. So this is the remainder. Now, according to the remainder theorem, f of -4 is -105. And that was what was asked. So we could have plugged in the -4 over here and done the calculation and gotten -105. We should. But again, this is another way of doing it. So we know that the remainder is going to be whatever we are dividing by. Okay? And just to, I know this is not asked here, but just to kind of review, we would write this. Again, the x is going to be, the degree is going to be 1 less than what it was here in the original. So it's going to be 3x squared minus 8x plus 27. And this is going to be minus 105 over, well, we have x equals -4. If we bring the 4 over, Now we're going the opposite way. We get x plus 4 equals 0. So this is what we're going to write on the denominator here. So the negative 105 comes from here. And then we need to write the divisor here, which would be x plus 4 in this format right here. Okay, we've got one more page here, which is the factor theorem. So if f of x, or f of x is a polynomial, so if f of c equals 0, then x minus c is a factor of f of x. So again, what this means is that there's no remainder because this is 0. If x minus c is a factor of f of x, then f of c equals 0. Okay, so let's see what this means. We are solving this equation given that negative 1 is 0 of that function. So what this means that if it is a 0, so f of negative 1 is going to be 0. So that means that x minus negative 1, which is x plus 1, is a factor of f of x. So what we're going to do is we're going to use c equals negative 1. So negative 1 is our divisor. These are all in descending powers, and there's nothing missing. So we're just going to write the coefficients 15, 14, negative 3, and negative 2 here. We're bringing the 15 down. Then we're multiplying negative 1 times 15 is negative 15. We are adding 14 plus negative 15 is negative 1. Negative 1 times negative 1 is a 1. Negative 3 plus 1 is negative 2. And negative 2 times negative 1 is 2. And negative 2 plus 2 is a 0. Okay, so what did we get? So our factor is going to be 15 x squared. Again, it's 1 less than what we had in the original, minus x minus 2. This and our other factor is the x plus 1 here. This is going to equal 0. So we are solving this equation. So we started with the factor theorem. Now we need to continue further, and we need to factor this. So the factors of 15x squared minus x minus 2 are going to be 3x plus 1 and 5x minus 2. I'm just giving you the factors. You will have to, know how to factor this out. If you're not sure, use the quadratic equation. And then x plus 1. Okay, now we're going to set each of these to be 0. So 3x plus 1, we subtract the 1, and we get 3x equals negative 1. We divide by 3, and we get x equals negative 1/3. We do the same thing here. We add 2. 5x equals 2. We divide by 5. We get x equals 2/5. We subtract 1, and we get x equals negative 1. So our solution set here is negative 1, negative 1/3, and 2/5. Okay, that's it for this lesson. Let me know if you've got any questions. Bye.